The universe. Throughout our history, we've looked at the sky to understand it. The universe is everything to us. In it we are born, grow and die. How did the universe come about? What are the things that have made it a universe? Does infinite space have any meaning? Scientific researches yields some important results. Big Bang, dark matter, dark energy, parallel universes.
We got something different going on down here. We are the same as the universe.
Neil deGrasse Tyson explains.
Super duper black holes lurk in the centers of galaxies and they beam rays out. I mean, they're destructive forces in the universe, and they're extraordinary for how much they're able to concentrate energy in a very small place. And if you fall in, you're never coming out, but everything else that tries to get in, it can't. It gets really hot and it radiates out in these jets. So that's a black hole jets. Because matter is trying to get in down the toilet bowl and it all can't fit at the same time. And it heats up in the effort to do so.
Super black holes are the largest black holes. They can be the size of billions of solar masses. It has a high gravity that slows down time, as in the Interstellar movie. However, they can also be fatal. Because around a black hole there is an irreversible field called the event horizon.
Now, dark matter, dark energy. We don't know what dark matter is. It's 85% of the gravity of the universe. It's something we don't know what it is. So we just call it dark matter. The universe has some pressure in the vacuum that's making it accelerate in its expansion against the wishes of gravity. We don't know what that is either. We call that dark energy.
It is assumed that dark energy is constantly expanding the universe and pushing galaxies apart. The universe has been expanding since the Big Bang. The rate of expansion increases over time. When scientists discovered this, they decided there must be an energy that increases this speed. This supposed energy has been called dark energy. The scientist, Alan Guth, was the first to talk about dark energy. He attributed the sudden expansion of the universe after the Big Bang to the presence of a mysterious dark energy in 1980. Later, two physicists named Saul Perlmutter and Brian Schmidt observed that the expansion rate of the universe increased. They suggested that this was due to dark energy.
This is the entire universe in one slide. Quantum fluctuations. There is the baby picture of the universe. That's that sort of aqua surface there. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky. There it is, the cosmic microwave background, a record of the earliest moments of the Big Bang. Then it takes a little time to make your first star. We call it the Dark Ages. Stars are made, galaxies are made, galaxies mature. We come up to the present day, 13.7 billion years later. It's a pretty coherent picture that we have of the origin of the universe. And here's that map. So this is a record, the earliest moments of the universe. And it tells us what the universe was up to.
All these takes us to the beginning of the universe. So to the Big Bang. The biggest evidence of the Big Bang, according to many scientists, is the cosmic microwave background radiation. This is a radiance left over from the Big Bang. It shows that the galaxies are moving away from each other. The universe emerged 13.7 billion years ago, in an explosion. The universe was initially hot and dense. It started to expand. Stars and planets had not yet been formed. It was filled with a uniform glow covered in a white-hot hydrogen plasma fog. As the universe expanded, both the plasma and the radiation that filled it got colder. When cooled enough, protons and electrons combined to form neutral hydrogen atoms. So the cosmic microwave background glow was born.
The Big Bang, by the way, could fit into a larger story. For example, the multiverse. Big Bang is probably not the whole story. It's probably a piece of a bigger story. So maybe there are multiple Big Bangs. This would give us the multiverse. We don't have data for this, but we have good theoretical and philosophical reasons to think that a multiverse exists. So here are these, each of these bubbles is a universe coming in and out of existence, and we're just one of them. And who knows how many universes there would be. This is very kind of spooky looking, but these are fluctuations, quantum fluctuations in the universe that spawn entire other universes. So it's an intriguing direction. So put this word in your vocabulary and watch it show up in news accounts. It may be that the dark matter is not matter at all. It's the gravity from ordinary matter from a nearby other universe in the multiverse, whose gravitational influence we feel. Really, it's just ordinary matter doing its thing in an adjacent universe. So a multiverse can give you some predictive power.
Dark matter is matter in astrophysics that does not interact with electromagnetic waves. The presence of dark matter can be determined by the gravitational effect on other substances.
Is planet Earth? You want to get a feeling for that, go listen to Carl Sagan recite his own words about a pale blue dot, where on that speck is everyone you've ever known, all wars that have been fought over temporary demarcations in soil that exists on that speck. How full of ourselves we are when viewed only from Earth. We are the same as the universe, and these elements are forged in the centers of stars. This is actually an image of the center of the galaxy, but there's stars within here that forge those elements, explode from what we call supernova explosions, scattering their enriched guts across the galaxy, enabling freshly born star systems to contain the basic ingredients of life itself. And this is going on in every single galaxy. This is our nearest large galaxy called the Andromeda Galaxy. It happens to be among the stars of the constellation Andromeda. That fuzzy spiral contains 400 billion stars. These other stars you see in the picture are sitting on our nose in our own Milky Way. It's as though we're looking past a screen door through the void of intergalactic space to another galaxy. If you pull out the power of the Hubble Space Telescope and say, I'm not going to look at this big galaxy, I want to look at an uninteresting corner of the dark night sky and show me what's there, this is what shows up. Every other smudge, every other shape in this image is an entire galaxy, from nearby to the distant universe. Every single splotch on this image. This is the Hubble Ultra Deep Field. That's what it's called. And you sit here and gaze upon it and recognize that every smudge is like our own Milky Way, containing hundreds of billions of stars, some of which are forging these heavy elements that comprise life, exploding, scattering themselves into their own galaxies. And it is this knowledge that we have of the universe, and our knowledge that we have of chemistry, and our knowledge that we have of biology that allows us to derive the conclusion that no, we are not apart and separate from this universe. We are one with it. I can say one better than that. Not only are we one with it, because these elements are forged in the universe, and they become part of life as we know it. It's not simply the fact that we are in the universe, but, ladies and gentlemen, the universe is in us. And I know of no more profound understanding or revelation that modern science can deliver but that. And for me, that makes me feel large, not small.
Will an asteroid hit the Earth? Neil deGrasse Tyson will explain. Subscribe to the channel so you don't miss the video. Thanks for watching.